Hello gamers, welcome back to another video. Today we will continue discussing the database reversing project, focusing on what fun things we can do if we control the file a database implementation will save the contents of its database to. Today we will be covering the Dragonfly database implementation. So now a bit about the Dragonfly database implementation. It is meant as a replacement for Redis, which is designed to be a super fast database used for things like streaming where time latency is extremely important. It has different data type implementations for things like hash sets, integer strings, and more. It can be accessed via a network client, and up to this point in the project is probably the most unique database implementation I've looked at in comparison to the others. And there's the GitHub link if you want to go check out the project. So let's show briefly how to actually use the database. You see right here is the compiled binary that we use to actually run it. So let's go ahead and run the server like that. We can connect to the database using the Redis CLI client. And we go ahead and see that key 0 does not have anything set for it. So let's go ahead and set a value for it. Let's say value 0, and then we see that the value is there. We can go ahead and dump the database contents with the save file, which you see right here. It actually saves the contents. And then when we restart the database server, we see that it go ahead and loads that file there. And when we connect to the database again, we see that that value does persist. So for the next part, I'm going to briefly cover the format of the database save file. I have much more details in the documentation associated with this. So starting off, we have the header, which is just the first 9 bytes. This right here effectively starts off with the string Redis, probably to designate what type of file it is, followed by an ASCII version, this one just being 0009. And that's it for the header. Now, the rest of the database file is broken up into individual pieces. Realistically, you have 2 types of pieces, either pieces of heap metadata, which is just information that describes the database, or you have actual records. The first piece that we have is this right here. It is a heap metadata piece. We can tell that from the starting value OXFA, which specifies the type, which is 250. And over here, this is just something that I pulled from the source code. We can see that correlates to the RDB opcode aux heap metadata piece. And effectively, now all of the heap metadata pieces in here will just be this like auxiliary type. There are several subtypes for the RDB opcode aux type piece. It's designated by the string that it starts off with. In this case, it is the Redis version, followed by a string that designates the actual version of it. Now, this piece covers here. We can tell that from several different ways. Before I do that, I want to cover string data types in this database implementation. It will start off by having a length of value that just specifies this is how many characters are in the string, followed by the string itself. Here we can see that size value is 9, and then following it we have 9 characters. And next up we have the actual Redis version for the value of this, which is just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just 999.999.999, and we see 11 is the size value right here. So that's it for that piece. Going through here, we see a few other heap metadata pieces. This one right here. This one's actually a bit interesting because we see right here is, I believe, an integer data type. We can tell that from the fact that the type value is OXC0. And then we see following it is the value OX40, that's the value of the integer. Over here, we see there is a long data type specified with OXC2, and the next 4 bytes are the value of that. Now, just going through the rest of the pieces in here, we have a piece right here, and the final piece is right here. I know this heap metadata piece specifies a Lua script that has to end with a null byte. And right here, we have our first actual database record. Now we can tell that this is 00 type value is one of the type values used for records. I believe it's used for the strings. And we can see here it starts off with the size of the key for the record, followed by the actual string of the key, followed by the size of the value, followed by the actual value of the record. And then we see that pattern repeats itself for the next two records, and then it ends off with an OXFF. That basically just means that it's the end of the database file, which we see that opcode being used right here. So one thing about this database implementation, my docs cover this more in detail, but as it's loading in a database save file, it will actually load in the pieces one at a time. And for the records, it will actually do a lot of checks on the size values we provide to make sure that it doesn't extend beyond where we say it should be. And because of that, we can't do a lot of the fun things that we could do with other database implementations, such as leaking records and that sort of things. However, take a look at this piece of heap metadata right here. Where does it end? And it's right here. What this does is it specifies a Lua script. Now, one thing about this database implementation that it has as a feature is it has the ability for you to actually load in Lua scripts and then run them. And you can actually save that in a database dump file. And what we can actually do if we edit a database save file is we can actually add in our own Lua scripts that can then be executed after the database file has been loaded. So next up, we will cover or show a demo of how we can actually edit the database save file to add in a Lua script that we can then later call. The Lua script that we will be adding in will just be this one right here. It will just simply return the string we added this code in. Now, how do you actually call a Lua script in this database implementation? You do so with the eval SHA command, where the first argument is the actual hash of the Lua script. We can get that hash with this command right here, which you can go over here, run it, and see that the hash begins with 483D and so on and so forth. And let's go ahead and try to actually run this script just to verify that it does not already exist in the database. So we can go ahead, start the server, let's reconnect, and let's go ahead and try to actually run this. And we see that the database does not have the Lua script. So let's go ahead and shut down the server. Now we will actually edit the database save file, which is opened right here, to add that in. Now to do this, I'm going to add in an additional piece very similar to this one right here. It is another RDB opcode aux piece. Effectively, it will just be another Lua script right here, and we'll just add it in. Here are the bytes that we're actually going to add in for this piece. I covered in the docs exactly why all the format of this piece, which we can then know exactly this is the cont or bytes that we need to specify. And for this, I'm just going to put this at the very end of the file. That way, I just have to, after I'm done adding in the bytes, I just have to put the OXFF piece, meaning I just ended the file, and that should be good. So I'm going to go ahead and type in the bytes right now. I'm actually going to pause the video while I do that. Okay, and just like that, we added in the final piece, which is right here. It's a auxiliary heap metadata piece that is a Lua script which we designate with the string right here. And the actual Lua code itself is another string, which we designate with the size volley right there, ox1e. And let's go ahead and save this. And now let's try to actually run the Lua script. And when we go ahead and run it, we see that the Lua script is now actually able to be executed. And just to make 100% sure that I'm not pulling any funny business, we see the dump file that is loading in dump 2022 06 25 20 21 10. We see that that is the actual file that I edited. So just like that, by editing the database save file, we were able to add in a Lua script that was then able to be executed by the user. So one last thing I just wanted to talk about. This really wouldn't be useful in any sort of attack at the moment. The reason for that is the ability to load in Lua scripts is able to be done by the user, and from what I can tell, there isn't really any sort of permissions in here that would prevent a certain user from doing that. Redis itself does have support for that type of permissions, and going through some of the code, you see messages like ACL isn't supported yet, which might lead me to believe that there are plans to implement something like that. If permissions like that was added and you had access to a user that could run existing Lua scripts but not load in additional ones, something like this might be useful.